Uh, hey everyone, welcome to the second to last week of Jumpstart. And today we're going to be going over database, like advanced database stuff that we didn't really go over last week. That'll really help if you're trying to do some more of the like powerful capabilities that SQL has. Probably should have skipped slides first. Yeah, Jumpstart 9th workshop. So just a little note starting out. This lesson and next lesson is probably going to be a bit shorter, just considering how we're, finishing up like a lot of the topics that we were covering. So expect these to be around like 30 to 45 minutes, I think. So today we're going to be starting off with some table constraints, which is more of what's called data definition language. And we'll be going over like primary keys, foreign keys, and a few other constraints that you can use to enforce certain kind of relationships within your tables. Really quickly, I just got a question. Will this cover anything more than CS 3200? This is actually just going to like touch the very surface level stuff. If you really do want like an in-depth like view of databases, definitely take the course. This is just like to get you started and stuff. So continuing on, we'll be going through some more advanced SQL queries. So like some more advanced select statements and stuff with things like distinct results, unions, aggregate queries, ordering case like joins and subqueries. So you've probably heard a lot of those before, but we'll be going over those a bit. So starting off with table constraints, we'll start off with primary keys. So we went over a little bit about this last time, and you've probably heard plenty about them, and even worked with them in some capacity. But it's important to take time to like really understand what they are and why we're using them. So primary keys really function as an ID to your table. It's really straightforward to see why they're so helpful. They let you identify specific rows. Whether we're programming on like the front end or the back end, it just makes it like really easy to identify specific entries in your database. Standard practice is usually to create like a column named ID. In Postgres, remember the data types that we talked about last workshop. We usually use serial for that since it's auto incrementing to serve as our primary key. It's usually like just like a short and descriptive and usually unambiguous name. Yeah, so like as we said last time, it stores an integer with auto increment. And every time we make a new entry, Postgres will automatically like throw in the next value in the sequence. This way, we really don't need to worry about setting it ourselves. But technically, it's more just a constraint. So you can actually make it whatever data type you want and have it be set to whatever you want. Another thing that we're really not going to cover in this course is compound keys, which means you can have multiple keys making up your primary key. But that's more of an advanced feature. It can be really useful at times, but for the purposes of this, we're just going to stick with the more simple stuff. You don't actually need IDs or primary keys for your table, though. It's just a nice way to enforce some constraints on your table. And right down here, you can see we've got just like a quick example of creating like a table of products with a primary key on it. Now moving on to foreign keys, we also briefly mentioned this last workshop, but what gives databases their power and versatility is their ability to establish some complex relationships between entities or entries in different tables. For example, let's say we were building like an e-commerce application or something with like a list of products that allows users to place orders of those products. So we start out with the products table from the previous slide. We got that right here. And we'll just create like a little orders table too. And what this will do is we'll create like a data relationship between this orders and this product products table by referencing this constraint down here. There's an inline way to do it that can be easier that we use in the script, which I'll actually send right now. I forgot to send that out. But yeah, this is how in practice, I think a lot of the time you use this notation for it, since you're able to reference your actual constraint here. And constraints are again, just ways to enforce data relationships and certain properties within your tables. So the foreign key constraint specifically, you can see here, foreign key, the column name. Notice how column names are wrapped in parentheses, references the product's ID. So that means this product ID is referencing this ID right here. And what that actually does is it means that the value you're inserting as a foreign key has to reference either a valid entry for the ID in the products table here, or it has to be null. If we were to create a new orders table in the slide with a foreign key reference to the products table, then that would ensure that orders can only be placed for valid products, which is in your application, that would be probably like a pretty important feature to have. So later on, if we were to try to delete or do certain kinds of updates to that foreign key reference, you could get an error, which again, really helps to enforce that data relationship there. Okay, so the schema back there worked really well if we wanted to make an order with a single product, but what if we wanted to make an order for multiple products? Again, going back on our orders table here, we've got just like a single order with a single ID that's auto-incremented, a user ID that placed the order, and a product ID. And then we've got our products table here, but what if we wanted to place a single order with multiple products in it? Does anyone have an idea of how to do that? No?
Can you rephrase the question?
Yeah, sure. So I'm going to go back really quickly, pretend you didn't see that. So right now, the way that it's working is we can place an order, a user can place an order for a single product right now. But is there a way that we can maybe redefine our relationships, maybe even create like a new table to create just like a single order with multiple products? Product line items? Sorry, what exactly do you mean by product line items? No response? Ah. Oh, okay. Duplicate your code for product ID, but rename them product 1 ID and product 2 ID. So really quickly, I'll address that first one before moving on to the next one. So if we were to have like one column, I think that's what Nick is saying there, one column for each product ID. That's okay if you have like a predetermined amount of products that you can buy. Like if you say, oh, I can only buy up to 2 products, that can work. But the issue with that is that you need to know exactly how many you need, and it's sort of not really flexible. So James came out with the right solution there. Almost, Nick, it was a good idea. But the correct answer is to actually create like a third table that links orders to products. So usually these are called join tables. And what we'll do here is we'll rewrite our orders table a little bit. So now it'll just have an ID and a user ID. So we still know who's placing the order. And our products table is the same, just an ID, a name of the product, and the price. So we've got our third table here, our join table, which is called order items, linking a product to an order. So you can have as many products as you want in an order. You just have one entry for each new product on the order. And you can have as many orders as you want too. And again, we're going back down here and creating these foreign key relationships right here so that we're able to enforce that relationship where you can't add a product to an order that doesn't exist. And you also can't add products that don't exist to orders. So really, really nice property there, especially in an e-commerce application like this. Really quickly, does anyone have any questions on that? Does that all make sense? I'm going to assume yes. All right, so you have a few more constraints to go over. And the first two that we'll talk about are unique and not null. They're pretty simple and self-explanatory. Unique just requires that each entry in a column is unique, and not null just requires that each entry in a column is not null. And you might have seen these from last workshop or even above. I think I had some of these constraints up above in some of the previous slides. But yeah, it pretty much just makes sure that the column enforces whatever data relationships you're expecting. And if those constraints aren't fulfilled, an error will be thrown. So actually, primary key is a combination of those two constraints with a little bit of extra feature. Primary key also creates an index, which we won't really go over, but it basically creates a really nice way of speeding up a search for a specific column at the cost of a little bit of extra space. So sort of similar to a hash map in a way, if you know about that, or a dictionary or anything like those. So the database that we're using in this, I have a question about the database that we're using in these examples. The database that we're using in this is Postgres, or PostgreSQL, or PostgreSQL, I don't know, however you end up pronouncing it. So do all databases support these language syntaxes? Yes, so a lot of them are very similar. Like I said, I might have said it earlier in this workshop, or it should have been said, I think, in the previous workshop, but serial is actually Postgres specific. Usually in other languages, it'll just be an integer with some auto increment constraint or something like that. Yeah, Liam's got the spelling there for it. In Postgres also, I don't know specifically if any others do, but I think numeric might be Postgres specific. I think there are other float data types that exist in other database systems. So if you want to try to find some equivalent, I don't know, data type or constraint in another language or in another database system, just look up online, just say whatever the database system is equivalent to look for the equivalent data type, and it should come up with something that you should be able to use that works either the same or roughly the same.
The only thing to keep in mind there is when you're looking at different types of databases, all the MySQL databases that we're using are, like Connor said, pretty much have all the same functionalities that we're going over. But you'll also see NoSQL databases, which are pretty different, and we're not really going to go into too much right now, but just keep that in mind.
Yep. If you want to learn more about NoSQL databases or some of the more intricacies of this, definitely take the databases course. It's pretty helpful, actually. So the next constraint that we're going to go over is called check. Actually, I think this is the last constraint we have for now. And check just guarantees an expression is true for every entry in a table. Um, so yeah, you can define a constraint like this, say constraint. You can just name the constraint whatever you want here. Just say the check keyword and then define your check. In this case, it's ensuring that the price is not 0. Um, you can also do a check using multiple columns. So if you wanted to, we can define like a discounted price column too. We can have a check that makes sure price is greater than 0, the discounted price is greater than 0, and that the price is greater than the discounted price if we wanted to. It's pretty simple. And yeah, so one little thing, one little side note is that um, another way to define check that we do in the script is we actually just say check in line with the column, and just so it could be like price numeric and then check and then price greater than 0. Um, there's another way to do it like that, and that's what's called a table or a column constraint rather than a table constraint. A lot of what we're doing down here are table constraints, which applies to the whole table, specifically where we can like check if two columns uh, have some relationship with each other or something like that. But if we were to define the one inline one, that would be a column constraint. So it would only affect the price column if we defined a check on that price right there. Moving on, let's go to some advanced SQL queries. So last week we learned how to construct some of the more basic select queries that read rows and columns from our database. But in the real world, data can be much more complex than just a list of rows and columns. Um, so some of we'll really go over some of those like advanced querying techniques right now, just to give us an idea of like how to use these more advanced features in SQL. One of the more simpler ones to start out with is distinct. If we wanted to select like all relevant rows from a table, but we only want rows that have distinct values, so any rows that aren't identical by some given criteria, then distinct is the keyword to do that. So it's sort of like the unique constraint before, but it's more for, or it's for selecting things rather than defining table constraints. So in this case, we can say select distinct name from products, and that will select each unique name from products. You can also apply it to multiple columns, so that can select the unique name and price from products if you wanted to do that for that second example. Pretty simple one. Another one is union. If you're familiar with a mathematical union, like combining two sets of data, this is pretty much the same thing. In SQL, it appends like the results of two queries, but their columns have to match. That's a very important requirement for it. If the columns don't match, you'll probably get an error. So you can just sort of do two different queries and combine the results. Here's an example where we just select the name and the price from products where price is greater than 50 or less than 5. This could be done in a single one, but we don't really have a complex enough example here to show you where unions are really powerful. But I guess one example off the top of my head right now is that if you had two different tables or two very similar tables, and you just wanted to get like, let's say you had the products table from before and the orders table with like a user ID or username from it. If we wanted to select all the product and usernames, what we could do is we could select the name from products, union the username from orders, but we'd have to alias the name, which I think we go into a little bit more detail below. So now let's go through aggregate functions. And aggregate functions allow you to do some like statistical functions or some very useful things with grouping, which is a little bit complex to think about at first, but they really become super powerful once you really get into it. The most common functions are count, min and max, average, and sum. So count it's a pretty common function used, and it counts all of the entries in a specific column, or all columns if like an asterisk is used. In this example here, we're selecting the count of entries for the price column from products. And in the second example, we're doing just select every row, like the count of all rows from products. And if you select count in your query, you'll get a single row with a single column representing that count returned to you. And we'll go over some examples of this in a few minutes. Min and max do the same thing, just return a single value representing the min or max value in a specific column. The asterisk doesn't really apply to this one, since it's a little bit more complicated than just selecting the count of everything. You really want to find like a specific value in some rows or in a certain column. And if you have some string ones or some string columns, might get a little bit messy with that. So this applies to a specific column only. Average and sum, again, like min and max, just average or perform average over all the column or all the entries in a column, and sum over all the entries in a column. So pretty simple until we get to grouping. So grouping allows you to combine the records to be returned by a column or multiple columns, which is a little bit weird to think about. But what this means is that all of the records in a column with matching values will be grouped together for whatever column or whatever criteria you specify, and a single row will be returned from them. But this might sound like a little bit like useless or a little bit weird, but what really makes it powerful is that aggregate functions can be applied over each of the items in that group, and you can get like a regular result of multiple values throughout like with like keys and values. And that sort of sounds like it's sort of hard to explain without showing you. So let's do an example. Let me just set this up real quick. Okay, does everyone see my Postgres window right here?
Yep. Connor, could you
Cool,
explain
okay.
what pgAdmin is for a second, though?
Oh yeah, so when you installed, or if you haven't installed it, when you will install Postgres, there's a little application you can download with it called pgAdmin, which is just like a way to interface with your database. So on the left here, you can see all the servers that I have locally. I've only got one, or even remotely, but I only have one locally set up. All my databases in there. We're specifically working in the Jumpstart DB right now. And our tables are down here under the schemas and tables. So this is what you might end up working on this week, splitting out your comments and post tables into comment collapse and post collapse table. So you can do some of the features that we're showing you today on those. So yeah, let's run a little query really quickly. Let's show you what we mean by grouping and aggregate functions. So if we get out our query tool here, we'll move this down real quick. So let's select everything from post right now. So when we run that, we get a bunch of results here. So pretty simple. You've seen this before a bunch. So what happens if we do select count from it? Does anyone know what will be returned there? Not the number of columns. Close though. It's very similar. Instead of going across, you go down. So it's the number of rows actually. So if we we do this, we should get 4 rows right here. So it should return 4. Again, if we do the same thing with ID or something, since all of those rows are filled in, we'll just get 4 right now. Let's go back to this really quickly, though. Does anyone know what will happen if we do, let's say, sum of ID? $77. Let's see. Oh, whoops. Oh, whoops. Yeah, sorry. ID, not all. Yep, 77. Good answer. Let's also do min and max, I guess. So what do you think? Actually, I'll go back really quickly, but what do you think min will return? 2, yep. 2 is the right answer. So I guess you can get the idea of what's going on here. So let's show you, so this is without grouping. Let's show you what happens with grouping. So I'm going to show you the post IDs table because that one is a little bit better for showing grouping stuff. Or sorry, the post collapse table. So let's get out our post collapse table right here. So here you can see a bunch of IDs and a bunch of post IDs. So you can see each clap here has its own ID, but some of these claps can belong to like a specific post. So if we run group by post ID on there, then we're going to start grouping by these post ID values right here. Since we're running a group by query, at least in Postgres and a few other database systems, you can only return values for things that are either being grouped by or running aggregate functions over. So in this case, we have to specify that we're only selecting post ID right now. What you'll see though is that we're getting just those 2 values. So these represent the grouped by results here. Let me get rid of that so you can see it all. I'm also going to throw that on the next line. So let's try something interesting. I'm going to go back to this so that you can see everything again, and we can do a couple examples of what happens when you group by and run aggregate functions over it. So if we group by post ID and we say, what if we want to select the post ID and count of all? What do you think this is going to return? This one might be a little bit tricky, but I'm sure you guys will figure it out. No guesses? How many rows for post ID 24 and 25? Yep, good answer, you got it. So what's really cool is that you can show, for each post ID here, you can show the count of how many posts are in, or how many claps are in there. Another thing we could do is, what if we wanted to take like the average value of the ID? So that'll be thrown in there too. Since it's numeric, it's got a really high precision, but yeah, so we get 51.5 is the average ID for this post ID 24 and 54.5 for 25. Yeah, and you can run a bunch of other interesting functions over that, but that's sort of like the basics of what grouping does. It's super useful, and yeah, you'll probably end up using it a lot if you end up doing some database work. Does anyone have any questions about this or want to see anything else while we have this open? I'm gonna say no. Oh, yeah, no, never mind. Okay. Back to the slideshow. So we just went over group by stuff, and we might end up going back to pgAdmin in a sec, but let's go over the having keyword. So usually when you run queries and stuff, you're able to apply like conditions on the results that are returned through the where clause. But what if you want to return some like results based off of like aggregate functions? You can't really do that in the where clause because where is performed on each row individually. So what we have is this having keyword, and that lets you perform where like operations on grouped callings with aggregate functions. So really quickly, does anyone have any idea what this is doing right here? No guesses? Okay, I'll go through and explain this really quickly. So specifically what this is doing is you're selecting your customer ID and the sum, the amount of money that they've spent from the payments table, grouped by the customer ID. So exactly what that's doing is you're selecting all of your customers and the total amount of all of their purchases here. But you're only returning them if they have that total amount of purchases greater than 200. So you'll only return customers that have spent at least $200 on purchases. Pretty simple, but a little bit different from where. So we could also do, going back really quickly, we can also do another thing where, what if we wanted to do, if we wanted to throw like a where in here, we could also rewrite this as select customer ID and the sum of all the total amounts from payments. What if we wanted to select where those payments are only greater than $5? So we could throw a where in there, say where amount greater than $5 grouped by customer ID having the sum amount greater than $200. So what that'll return is the total amount of payments that have products worth at least $5 and like a total amount greater than $200. So yeah, I don't think I'm going to go back to pgAdmin because I don't have a great example to show right now, but I can, I think I can whip one up by the end if anyone wants to stick around and see it. So continuing on, order by is another pretty simple one. It lets you order your results. So you're allowed to specify whether you want certain columns. Oh, I have another question about having and where, so I'm going to go back to that real quick. So having lets you perform wheres, like the where limiting or where filtering over aggregate functions. But where is performed on each row. Does that make sense? So where is performed on each row, whereas having is performed on a group by, like the returned group. Cool, yeah. It's a little bit weird when you first think about it. So sort of just it'll probably come to you, like probably start making sense once you've worked with it a little bit. So order by, again, lets you order your results. So you can specify whether you want the columns to be ordered or the rows to be ordered in ascending or descending order. And you can also break ties by multiple columns. So in this example here, we're selecting everything from products, ordered by price ascending. So smallest price first, biggest price at the end. And then if there are two products with the same price, then order it by their name next. So Z first and then A first, since it's descending order. Pretty simple. Sure, you'll be able to figure that out if you end up wanting to use it. Case is sort of like an if-else statement in SQL. It allows you to evaluate certain condition and then act differently depending on the results. A lot of the times it's performed in the like column part of the select statement. So in this case, in this example right here, we're selecting the order ID, the amount, and then something as the payment due description, depending on results returned. And so what this case statement here is doing is if the amount returned is greater than 10, then it returns this string. If it's less than 10, then it returns this string. And if it's exactly 10, then it returns this string. And then it just renames it as the payment due description. Yeah, so in this case, that third column can end up being like really flexible and you can end up doing a lot with it. You don't use these super often, but they're still nice to know about so that you can just look it up whenever you end up wanting to use it. I think we're nearing the end here. So like is, I think it was also mentioned last week, but it's super useful in where clauses, and it lets you select string values that are similar to other strings. So the two wildcards that you need to know are like the % which is like the asterisk operator in regex, representing 0, 1, or more of any character. And then the underscore, which is like the period operator representing exactly one character. So does anyone know what these queries are doing down here? No one? I'll do the first one. Let's see if anyone can come up with the second one. So this first one, what this first one is doing is it's selecting something. So because it's got an underscore starting out, so this can start with any character right here. So it'll be one character in the front, and then since this is 0, 1, or more of any character, it's got anything S and then anything else. So this can be represent like again 0, 1, or more characters. So what this is doing right here is it's saying it's selecting any word where the where S is the second letter. Right? Does that make sense? Yep, Nick came up with the second one too. So second one is any word or any product where the name starts with an S or ends with an S. So glad you guys are getting it. It's pretty useful. You don't end up using it super often, but it can be nice if you're looking for similar strings. So now on to joins. So you might have heard about joins before in SQL if you've ever worked with it before. Super powerful, and you really do need to learn about them to do some of the more interesting queries. And what they do is they allow you to combine the columns of two tables and produce like a single row on some condition. So in this case, what we're doing is we're selecting product IDs, product names, and order IDs from the order items table, so that join table, where the product ID is equal to the product ID on the other table, right? So really quickly, just note the O right here and the P right here is a table alias, which is similar to the column alias we have right here. So we use as for column aliases and just a space after the table name for the order alias. And you can make those don't have to be like a single character or anything. You can make it however long you want. I just used O and P because it's pretty simple there. So what this is going to do is you're going to be selecting the product IDs, names, and the order IDs for each product in the products table. I'm actually going to show a quick example. Oh, I think Zoom is dying on me right now. Oh, okay. I found the share screen button again. So really quickly, going back, let's try to do a join and show you exactly what happens from it. So again, we've got our post collapse table. Show you what that looks like. It's all of these. We've got our post ID there, and let's go check out our post table. So in post, we've got like all this information too. So if we select all from posts join, so let's do posts P and posts or collapse PC on P dot ID equals PC dot post ID. What this will do is it will return all of the fields on the posts table and all of the fields on the comments table matched where the post ID is equal to the post.id. So let's run that. And here what you can see is, so we've got like the same thing as we had before here. But everything's been duplicated. So what happens is every time there's a match, a new entry will be entered. And since we have multiple post collapse, these posts will be duplicated here. So scrolling over to the right here, you can see that the post tables information, or the post collapse tables information, is also here. Does that all make sense? Or any questions about this? Okay. Let's go back to the slides. So for joins, there are a couple different types of joins. There's the inner join, which is what we just did, and it returns the rows when there's a match in both tables. If you noticed before, we had a bunch of different posts, but not all of them had collapse. So in that result that we got at the very end there, only the posts with IDs that were matched with existing collapse were returned. But you don't need to have that behavior. There's also the left join, right join, and full join. So the left join returns all results from the left table, even if there are no matches for the on clause in the right table. And the right join does the same thing, but for the left, or it sort of just flips that. And then full join returns all rows from both tables, even if there are no matches for one of them. Yeah, so really quickly, just going back. Oh. If we go back to here, we're to say left join, you'll notice that everything should be a couple more entries are over here. So we've got posts with ID 2, 26, 2 and 26, which have all null entries right here, and they weren't there before since there were no posts that could be joined, or post claps that could be joined with it. All right, so I think the last thing on our agenda today is the subqueries. I think we spelled that wrong, but oh well. And subqueries are basically just queries that can output like a whole result or a single value that you can use within other queries. So they can get pretty complicated. So we'll just go over like a pretty simple example. In this case, yeah, here's just a simple example. Can anyone guess as to what's going on? Thanks, Sadaf. No guesses? Yep, James came back with the right answer. So in this case, it's selecting everything from the products table uh, if that product has been ordered at least 5 times. So you could also do this with a join too, if you wanted to. And you can combine joins and group by clauses to get like some complicated results. But here's just another way to do that similar thing. So you can definitely do some complex behavior with subqueries. So that's all we had for this one. Next week, we have our last workshop, the project wrap up and cloud deployment workshop with, it'll be
Not next week, Connor.
Oh, sorry, not next week, the week after. Sorry, I'm so used to saying next week that, that just came out. So it'll be in 2 weeks. We'll be deploying on Heroku, which is like a cloud deployment service sort of operated by Salesforce. So yeah, definitely recommend you come join us for that. Please fill out our feedback survey and let us know how we did. Thanks for coming.
Thanks, everyone.